Hello, everybody. I'm Isabel. I'm a PhD student in the INEA. This is pretty much the index I'm going to follow. First, an insight in wildfires, then what's happening in wildfires in Spain. I'm going to go through the different data that we use. First, the vegetation classes map, a fire cartography map, and forest structure. Lastly, I'm going to show you some preliminary results and future steps that we might follow. Yeah, you might remember this image for the keynote session. This is fire distribution in 29th of September, the day I took the flight here to Brazil. And yeah, so wildfires is a global issue. There is a global wildfires all over the world. So they act as a disturbance, affecting forest structure, and modifying the resources. So we thought that it would be interesting to study these wildfires here in Spain. So we are all across the Atlantic. Yeah, compared to Brazil, we are a teeny tiny country, but we are the second largest country in Europe. Yay. And this is how Spain looks like. We have 50 million hectares, 27 is forest cover, 27% is forest cover. We've got 46 million inhabitants, most of them living in the city. So yeah, we are experimenting some rural abandonment. We've got 4 main climatic regions: temperate, Mediterranean, mountain, and subtropical, which leads to many different forest types, as you can see in the pictures. So what's happening with wildfires in Spain? Here on the left, you've got this, this graphic about the wildfire incidents from 1974 to 2010. As you can see, number of fires reduced over since 2006. However, the size remains the same. So we have less fires, but more area burned. And in the right side here, burned area in forest cover. As you can see, there are like 3 main hotspots here in the northwest, in Extremadura, and in the west in Valencia. So we are going to focus in this hotspot. It's called Sanabria. It's about 1 million hectares, and 34 of the area is forest cover. As you can see, inside the area, we've got different area affected. So yeah, we want to evaluate the effects of, in the last decades, of wildfire regime in this area. As I said before, we've got these 3 databases. First, we need a forest map. So we take this Spanish forest map. It's freely available, and but we focus on those forests of our interest. Those are the forests studied: dense forests and open woodlands and shrub. We've got the pine forest, pinus forest, mixed forest, and eucalyptus and broadleaf forest. And for fire cartography, it would sound familiar for someone of you. We apply this composite to change algorithm developed by the Canadian Forest Service and the University of British Columbia. So pretty much my colleague Cristina Gomez, and in collaboration with those institutions, cartography the fire occurring in this area. For that, they used Landsat time series from 1984 to 2016 to analyze the trend of the NPR index per pixel. Oh, sorry, yeah. Here's some references if you want to check this composite to change algorithm. So as I was saying, they analyze per pixel the strength of NPR and check the breakpoints in this time series. Maximum, they can analyze 2 changes. Here's the result. And so pixel with similar changes will aggregate into polygon, and then with a random forest algorithm, they will see which change is occurring in those pixels. So we focus on the changes affected by fire, by wildfire. So this is the resulting map of the fire regime characterization, and we've got these 3 variables. We use these 3 variables: the recurrence, the severity, and the time since fire. As you can see, there are some pixels with no wildfires and others with 1 wildfire and up to 2. And for the forest structure, in Spain, we've got this National Plan for Aerial Orography. We've got freely available LiDAR data. The bad news is like the density is quite low. We've got 0.5 points per square meter. So we download up to 3,000 LiDAR tiles, and from the year 2010, and we did the point cloud normalization and obtained 19 statistics in this area. From all these 19 statistics, we wanted to reduce and to focus on those with more interest. So we analyzed the canopy cover, the canopy height by the percentile 99, the percentile 25, the height diversity. So I was wondering which index may I use. So looking up in the bibliography, I'll find out this paper by Listopad, applying Shannon index in LiDAR. And we also applied the canopy relief ratio, the CV, and the beta diversity by studying the standard deviation of the percentile 99. Yeah, finally, we've got these 3 databases. So we cross these vegetation classes with a fire regime characterization. So for instance, if we have this Scott pine forest, we will divide into Scott pines forests affected by no fires, 1 or 2 fires. And we've got the variable of the severity, time since fire, and the LiDAR variables, the structure variables. So here, we have these first results. You can see all forest types were affected. Almost 40% of the area was burned at least once. The vegetation less affected was the broadleaf and the Pinus sylvestris forests, and the most affected the shrubs and the dense Quercus ilex, evergreen broadleaf. Sorry. Here, the effect of the recurrence on forest structure. We analyzed 2 main variables, the height and the height diversity by the percentile 99 and the LiDAR-based height diversity index. So, yeah, what we can see here is the high recurrence reduces the height and the height diversity, and the effects are more evident in broadleaf forest and Pinus sylvestris forest. Yeah, here we have a bunch of numbers, but what I want you to focus is on these 2 data. This is the effects of time since fire in the different forest structures. So as we can see, the Pinus pinaster forest and eucalyptus forest show the highest correlation with this time since fire. This might be because of the fast-growing species. And in general terms, the vertical structure recovers as time since fire increases. Here, another bunch of numbers, but just focus on those 2. This is the effect of fire severity and in the different type of forests. Here we analyze only the severity 2. That's mean only in fires in those pixels where we have 2 fires, because in the others we haven't got that much results. So as you can see, in the broadleaf species, the fire severity affects mainly in lower vegetation layers. And from the Pinus pinaster forest, the height and the vertical diversity decrease when high recurrence and severity. And the future steps maybe incorporate the 2016 LiDAR flight in this area, and maybe extend the area, or incorporate other factors as climate change variables, climate variables, soil variables. And this is some preliminary analysis, so please, if you have any suggestions, ideas, I will be glad to hear and to implement in our future steps and future studies. So thank you very much for your attention.